In this video, we will explore the water content of soil and its determination. The water content of soil is a crucial factor that significantly affects soil behavior. It is defined as the ratio of the weight of water to the weight of solids and is typically expressed as a percentage ranging from 0% to more than 400%. To determine the water content, soil samples are collected from the field. Hand sampling is used for soil near the ground level, while soil samples at greater depths are collected during geotechnical drillings. The samples are brought to the laboratory to determine the water content. Based on the collected samples, the water content by depth can be established. This can help classify the soil and identify the soil stratigraphy. The water content can sometimes be correlated to the properties of the soil as well. The collected soil samples are brought to the laboratory in plastic bags or similar to minimize water evaporation. The initial step in determining the water content involves weighing a small container labeled as W1. Subsequently, a soil sample is introduced to the container and its combined mass is labeled as W2. The soil sample is then dried in the oven at 105 to 110 degrees Celsius. The drying duration varies based on soil type, with a suggested 16-hour period for fine-grained soils such as clay and gyttja and 4 hours for coarse-grained soils like sand and gravel. However, it is customary to extend the drying process to 24 hours to guarantee complete water evaporation. Once the soil sample has been dried, it is removed from the oven and allowed to cool. The dry sample can be cooled at room temperature and weighed within 1 hour. This time constraint is in place to prevent the soil from absorbing atmospheric moisture. Alternatively, the dry soil sample can be cooled in a desiccator where a vacuum is created to prevent any intake of moisture. Following the soil's cooling period, it undergoes another weighing process. The combined mass of the dry sample and the container is denoted as W3. The calculation of water content involves utilizing W1, W2 and W3. In this context, the numerator represents the mass of water, while the denominator signifies the mass of the dried soil. If we assume that the shown set of parameters has been obtained from an arbitrary test, the calculated water content is 175%. The water content in soil exhibits significant variations based on factors such as soil type, structure, and depositional environment. The table shown illustrates specific soil types' general water content ranges. If you enjoyed the video, don't forget to hit the like button and subscribe. This marks the conclusion of the video. The presented table outlines the variables used and their corresponding units.